Hi, everyone. My name's Ryan Nienhuis. I'm a product manager for Amazon Web Services. I work on the Amazon Kinesis team. So we've a very short presentation. I'm going to leave a lot of time for Q&A since it's toward the end of the conference, and I know attention spans are a little bit short. So what we're going to do is we're going to cover basically a brief overview of the service offerings that we have related to streaming data. I'll cover a little bit more in depth around our service, Amazon Kinesis Data Analytics, which is our fully managed service for Apache Flink. I'll cover 3 different options that you have for running Apache Flink on EMR, and I'll cover them very briefly. The reason being is because I'll spend most of my time on the last slide, which is basically a high-level overview of how we built Amazon Kinesis Data Analytics. The reason why I'm doing it is twofold. It covers kind of the value prop of what we do with Amazon Kinesis Data Analytics and how we run Apache Flink. The other is, if you choose not to use that service and say want to run it on our Amazon Elastic Kubernetes service or Amazon EKS, it gives you an overview of how we did that. Because Amazon Kinesis Data Analytics is built on native AWS, using AWS services. You can replicate a lot of what we've done with the service, and this presentation will give you a very small part of that. So with that, cover a high level of the streaming data services that we have at AWS. So the first is a service called Amazon Kinesis Data Streams. It is a streaming storage service that allows you to capture, store, and then process streaming data. So the way you interact with the service is you create a stream, and then you have a set of data producers that call a put API to write to that stream, and a set of data consumers that call a get API to read data off of that stream. So at an API level and the types of use cases, it's very similar to Apache Kafka. So with that, we also have on the very far end of the screen a service that we call Amazon Managed Streaming for Apache Kafka. This is very similar to Amazon Kinesis Data Streams in the use cases that it provides. However, it is a native Kafka experience. So instead of creating streams, you create a cluster, and then you create topics on that cluster to read and write data from those topics. So we handle a lot of the security associated with that, the underlying instance management and disk management, and scaling. We also offer a native API experience, so access to the cluster is brokered through our identity and access management services, that type of thing. So those are our 2 streaming services. In the middle, we have 2 of our kind of stream data processing service. The first was, I'll cover, was Amazon Kinesis Data Firehose. It was covered a little bit on the keynote this morning, but it's really about moving data from point A to point B. So you can write data to a Kinesis Data Firehose and then configure it to deliver to a destination. So the destinations that we support are Amazon S3, Amazon Elasticsearch Service, Amazon Redshift, and Splunk. And essentially the way it works is it's almost like a managed stream or Kafka topic and a delivery app, combined without you having to write any code. It only really works for simple use cases, but for those simple use cases, it works very well. So if you're writing to your data lake and say you just want to buffer records into larger files, do some minor transforms, it does that well. So not really the topic of our conversation today, but just wanted to cover it very briefly. The last is Amazon Kinesis Data Analytics, which the rest of the presentation will be about. Amazon Kinesis Data Analytics allows you to build a serverless, stateful stream processing application using Apache Flink. We'll cover that in a little bit more detail about how you use the service with Flink. So there are 3 ways that customers commonly run Apache Flink on AWS. Amazon Kinesis Data Analytics, which I just mentioned, Amazon EMR, and Amazon Elastic Kubernetes Service. They vary pretty wildly in the experience that you have. So with Kinesis Data Analytics, the experience is you build and test locally, you get a jar, you upload the jar, and then for the most part, the rest of the infrastructure is handled with us. So we manage the underlying Kubernetes infrastructure, we manage the underlying Flink infrastructure, including logging, metrics, security, scaling, and a lot more. You do sacrifice flexibility in that model. So, for example, we choose the state backend. We run on RocksDB. Our distributed state backend is Amazon S3. You don't get to choose that because we manage it on your behalf. On the other complete end of the spectrum, we have Amazon EKS, which you can run, basically you run all of the infrastructure yourself, so you can make your own choices. So if you want to use a different state backend, if you want to load additional libraries natively in your clusters, if you want to do logging differently, if you want to customize your Flink infrastructure, you can do so using a standard Kubernetes deployment. Amazon Elastic MapReduce Service, or Amazon EMR, is somewhere in between. So you can still choose an instance. You can run Flink on that as instance. It handles some automatic scaling capabilities to you. You must manage the infrastructure, but for the most part, you get the flexibility with a little bit less cost. So at a high level, what are the advantages and disadvantages of the various options? So both EKS and EMR allow you, for example, to choose your instance. So if you want to run on compute-intensive infrastructure versus memory-intensive infrastructure, you can do so. Amazon Kinesis Data Analytics is a serverless offering, so meaning that we abstract the underlying instances from you. This allows us to offer better automatic scaling capabilities. It also allows us to offer unique availability characteristics because we're able to fail over on hot fleets, that type of thing. So your unit of capacity with Kinesis Data Analytics is what's called a Kinesis Processing Unit, or KPU. It's 1 vPCU, 4 gigabytes of memory, and associated disk, and that's explicitly tied to Flink's parallelism. So when you create an application, we can automatically scale you with the parallelism, or you can say, I would like an application with 1,000 parallelism, as well as 1,000 cores associated with that parallelism. Or you can oversubscribe your CPUs. We allow you to tune that, as well as offer all of the built-in parallelism settings that you have with a Flink application or a Flink job. The only difference is that you do not get to pick your underlying instance. So the other things that EMR and EKS provide is you get fine-grained control over your cluster and infrastructure. So if you have a specific way you want to do your logging or do your metrics, if, for example, you want to send it to your monitoring vendor of your choice, or you want to send it to Elasticsearch cluster, you do so directly using Prometheus and the built-in logging infrastructure within Flink. Whereas Kinesis Data Analytics, our monitoring infrastructure is built into Amazon CloudWatch. So AWS's monitoring service. So all of the Flink logs get sent to CloudWatch logs. All of the metrics get sent to CloudWatch metrics. There are ways to get data out of CloudWatch into, say, your monitoring of choice, but by default, we're built into AWS. Same thing when you interact with your Flink application, you do so through native AWS APIs. So the great benefit of that is that you have identity and access management built into the APIs. They're secure APIs out of the box. We also handle all of the compliance certifications and everything like that. Everything's encrypted at rest, and there's network isolation built in. So that's the great thing associated with it. However, you don't get to directly use the Flink REST APIs, which are a little bit more flexible for managing your Flink jobs. So again, the theme here is that we're taking away some flexibility. You're getting a lot of management with that loss of flexibility. Again, on the flip side, on EKS, you have to manage all this, but you get to choose exactly what you want to do. So if you want to use Prometheus to send directly to Elasticsearch, your own self-managed Elasticsearch, you do so using standard Flink infrastructure. EMR also gives you some of that flexibility, but it's with some caveats. So for example, the underlying instance monitoring as well as some of the cluster monitoring, it's sent to CloudWatch as well, but you also get to make some choices there too. So how do I run Apache Flink in Amazon Kinesis Data Analytics? So after you have a jar ready, built-in IDE, you essentially upload your application using an API. We have what's called a create application API call. So you specify either in the actual API call or specify an Amazon S3 object location, and then we'll create an application associated with that jar. You then call run application, and then we run the application. So there is no messing around with setting up the Flink cluster, setting up the Kubernetes infrastructure. We do all that on your behalf. So we offer the CRUD infrastructure basically on your Flink jobs for you. After that, we'll automatically scale your application. I'll get into a little bit more detail about how we do that on I believe, the next slide. But you can also override our automatic scaling capabilities and directly provision compute and other infrastructure. So what do we manage versus what do you own? when you use Kinesis data analytics. So I mentioned the first thing that we manage is the application lifecycle. So for example, you upload a jar. If the upload to your Flink, if your job fails, we handle retrying, updating the application, and then eventually failing the update as well as logging what happened associated with the update. So you don't have to manage that. So we offer basically idempotent updates to your Flink jobs through our own managed service. We fully manage the state backend. So for example, when you make an API call to update your job, we'll take a save point, update the job, and then stop the job and then update the job on your behalf. So you don't have to manage that life cycle of the state. We also will maintain up to 1,000 snapshots for you, or save points rather, on your behalf that allows you to quickly restore from one of those save points. So you can say, basically list all of my save points, you can name your save points, we have timestamps associated with your save points. So restoring from a save point that you took 6 months ago takes like very, very simple, quick call on your application, since we manage that on your behalf. I also mentioned all the underlying Apache Flink infrastructure we manage on your behalf. So this includes the logging infrastructure, all of the control plane, as well as the Kubernetes control plane. So this is a really, really simplified architecture diagram of what we do when we run your Flink application. So it's grossly, there's a lot of missing components that I have here, but you can generally see what happens. So you, the user, are the green dot on the very left-hand side of the screen. You issue a API request that hits basically a web server, and then we take the metadata associated with that request, whether it's a create application, delete application, so on and so forth, and we store it into DynamoDB. From DynamoDB, we basically take change off of the database, basically CDC off of the database to start processing messages off of that change and update your application. So that application lifecycle management has several components associated with it. First is the component to interact with the Flink infrastructure. So we spin up a cluster and we spin up a job within that cluster. So every single application in Kinesis Data Analytics has its own Flink infrastructure, Flink cluster, and its own Flink job. So we also isolate it at the network bounds through Kubernetes. So we handle that for you. Our Kubernetes infrastructure, when we have this application lifecycle manager, basically picks the cluster that you're going to run on based off of the size of the application. So if you have an application with one parallelism and one core, you get put on a Kubernetes infrastructure with relatively small instances. So more explicitly, you get put on a node that's two cores, right? One core is used for your application, the other is used for all the other components associated with your app. If you ask for a 1,000 parallelism app with 1,000 cores, we put you on very different machines. We put you on big, beefy machines. You're still distributed, but we choose that based off of the size of your machine. The same thing occurs when we automatically scale you. So the second component, we have a health monitoring app that basically not only manages the job health, but also manages the scaling. So as we monitor your application, we identify, like, say, your CPU bound. We'll scale you between clusters and machines on your behalf. So you don't actually have to manage the underlying capacity. So, for example, we have an instance type called an M5, moving you from an M5 to a different instance type or a different instance size. We maintain fleets of all that. You don't actually have to pick the instance. So whether you're CPU bound or memory bound, we do that on your behalf. When things go wrong, the health monitoring app is also what identifies the things that go wrong. So for example, if your job failed to update, if you're running out of memory, or like if you have an error or something like that, that's where we'll identify that, we'll restart the cluster, we'll log that we restarted the cluster, we'll log that we restarted the job, and we'll continuously do that. So you can set up alarms that on either the logging infrastructure through CloudWatch logs or the metrics, basically identifying that we've restarted your job so that if you need to intervene, you can do so. So that gets kind of into the barrier of what we manage versus what you manage. So we manage the infrastructure. It's still your job to basically make sure your application code runs correctly, is not running into errors, doesn't have any like long-running thread leaks or things like that. We don't manage that on your behalf. We do some things with the Flink configuration to try different, what we call application profiles. So if, say, we load you with one configuration and it doesn't work, or we're scaling you and all of a sudden your application breaks, we are able to identify specific issues and move you to different application profiles to help more optimally run your application. But at the end of the day, if your code is broken, we can't fix that on your behalf. So there is sort of like a dual responsibility between what we do as well as what the customer does. So the final things that I'll cover on the slide before I just open it up to Q&A are the other things that we do associated with the application. So I mentioned automatic scaling. We handle attaching local disks or EBS volumes to your instances on your behalf, as well as burning those basically disks after you drop your application. So this is how, for example, we obtain GDPR compliance. So you create an application, you want to get rid of any data that you store in the application, you delete the application, we get rid of the EBS volumes, we make sure they're clean, we get rid of all of the S3 objects associated with your save points in order to complete that. We use, I mentioned all data is encrypted at rest and in transit. So we have a service called AWS KMS, or Key Management Service, that we use under the covers to encrypt everything with rotated keys. So every single application gets its own keys. We rotate them upon application updates. You don't have to manage that at all. So this allows us to run a very secure service and achieve all of the other compliance certifications that I mentioned, like PCI, ISO, and HIPAA. I think that's where I'll stop. I'm happy to go into more detail and any other questions, but I think we have about like 5 or 10 minutes left, and I'll just answer questions for the rest of the time. Okay, so to repeat the question, and please correct me if I'm wrong. Basically, you have existing checkpoints or save points. How do we manage them? How do we implement the checkpoints? How do I restore from a save point? That type of thing. Oh, great. I understand. How do I add it to Amazon? So that's actually one area that I would say is like a product gap. So the way the scope of your save points right now is scoped by the application. So the only way to like basically load application state from a fresh application is to make sure that it's included in your application code, all right? So like, for example, you either read it from S3 or read it from other store to load that application state. This is also an issue when you're actually migrating between applications. So if you're say, I'd like to take the state of one application and move it to another application, the only way for you to do so is through your Flink job. So you can't take advantage of the underlying like Flink infrastructure to basically just this save point, I want to start with that app because it's scoped to the application right now. This is definitely something that we're working on to address, but hopefully that answers your question, does it? Yeah.
Is there a walkthrough of how to get the word count app to follow this pattern?
How to get the word count app?
Yeah, is there documentation how to get word count to work following this pattern?
So you mean like the standard Flink getting started word count?
You said part of the pattern was I built a jar locally using my IDE,
yes.
And then the process to deploy it up to Kinesis data analytics. Is there a walkthrough that says how to explains how to do that?
Yeah. So there's so first of all, the standard word count app in the Flink documentation should work with little to no modifications if you just upload it. All right, because we run standard Flink infrastructure.
The upload part is what I'm.
Oh, so you would basically you can do so with the.
Is there a walkthrough that says how to run that?
Yes. So on the main documentation that we have, in the first getting started guide, we walk you through how to upload a jar to the service. There's two ways to do it. One is directly through the API. The other is you can save it to S3 and then just say, load that jar when you run the application. Does that answer your question?
Okay. Is it me or the? Okay. So I was just making sure that you were pointing at me.
Yes,
is this going to be maybe this may be stupid, a bit of an uninformed question. I just want to confirm my understanding of what Kinesis offers in general. So my understanding is that one can deploy Flink on the managed Hadoop service, the EMR. You get the benefits of EMR in that case. And obviously the Hadoop infrastructure. You can also deploy on Kubernetes, the managed service that you offer as well. In that case, you get to not worry about load balancing and scalability and so on and so forth. However, if I want to somehow not worry about scalability and load balancing, but also get the benefits of the Hadoop infrastructure. I wouldn't be able to deploy Flink in Hadoop infrastructure inside Kubernetes, right?
So when you say Hadoop infrastructure, so the question is, if I want to take an Apache Flink application, I can deploy in Amazon EKS by loading basically Hadoop infrastructure. So just taking your question on a more, like a little bit more broader of a statement. So I would say, and the reason why Amazon Kinesis Data Analytics runs on Amazon EKS and Kubernetes is because we believe the best way to run highly available Flink applications is within Kubernetes, okay? So with that, the way you would set that up is you'd set up your Kubernetes infrastructure, then you'd follow the best practices associated that are well documented in the Flink documentation with loading all of the dependent libraries, all right? Setting up your control plane within Kubernetes, setting up your, when I say control plane, your Kubernetes control plane, and then your Flink control plane, and then your Flink cluster rather, and then loading a job there. So that's how you would do so on the Amazon EKS.
Question on that.
Yeah.
What do I miss if I do that compared to if I had done it on Amazon EMR?
So EMR, you can spin up a cluster through an API call, and it loads all of the libraries for you on your behalf, right? And it loads, make sure that all of the supporting infrastructure is set up, right? And then you immediately go from the EMR clusters up to your calling the REST APIs within Flink to spin up a job, all right? Whereas with EKS, all of those steps that I just described for EMR, you have to run yourself.
Okay.
So you have to start up the cluster, you have to provision the instances, you have to provision the EKS cluster, you have to then provision or add all of the libraries and set up the EKS cluster, and then you can finally run the job.
But I do have the benefits of the Hadoop ecosystem, right? In terms of how the performance of my job, I would be able to get some benefits. For example, if workers store the data in a different way in the HDFS system.
I follow. So EMR also has benefits that they have optimized HDFS on Amazon S3, but this is what I would say, that the performance of your application is determined much more by how you design the app or the job than whether you run on EMR, Amazon Kinesis Data Analytics, or Amazon EKS. It's much more determined on that. I think we have time for one more question, and then I think...
Thank you.
May I?
Yeah.
So I have actually, so since when this is available, this service, is it pretty new or?
Amazon Kinesis Data Analytics has been available for 3 years. However, things like the
Support
application lifecycle manager, we did that with a different runtime, not Flink, for 3 years, all right? Same thing with the app health monitor. Yes. The biggest difference is this infrastructure and the ability to run a Flink job is about 8 months old, all right?
Flink, okay.
Yes, so so some of our infrastructure is old, some of our infrastructure is new. The Amazon Kinesis Data Analytics and the ability to run a Flink job was shipped at reInvent last year, so November of last year.
Okay, and maybe another thing, so how does this auto-scaling work? Because if I define the parallelism myself and then upload it, and then I define everything, so that doesn't mean so if Amazon scales out automatically my application.
So the question is, how does the automatic scaling work, especially if I define some of the parallelism? Yeah. So essentially, there's ability to set on a top-level API parameter whether you want the service automatically scaled or not. If you have that automatic scaling set, there are certain parameters in the parallelism that we just completely override. So you're still able to set like the maximum parallelism and things like that, but if you set operator-level parallelism in your app, and you have automatic scaling set up, we override them and just ignore it, all right? So when you provision the app yourself, you turn automatic scaling off, and then you have all of the controls that you have with Flink. So you can set this specific operator at this parallelism, a specific operator at that parallelism, or you can just set the parallelism for the entire job, right? The way automatic scaling works is our automatic scaling heuristics work very well for apps that are embarrassing parallel and CPU bound. All right. So what I mean by that is work is very evenly spread across the job. All right. So like a streaming extract, transform, and load job where you have a key buy with a very, very evenly distributed key, and most of your workload is CPU bound. So We scale up your application in almost like a stepwise function, but not exactly, based off of every 5 minutes based off of you hitting a certain CPU utilization, and then we scale you back down much slower in the same stepwise function based off you hitting a certain CPU utilization on the low end. We don't recommend turning on the automatic scaling capabilities, for example, if you have one operator that is massively resource intensive versus the other operators. In that particular case, we just say, don't you rely on the automatic scaling, set the parallelism yourself, use these n number of metrics to determine whether you're appropriately scaled, and then trigger a scaling action after the fact. The way you scale the app provision resources is through an API call. So you say, I want an app, I want this parallelism, and I want this parallelism per KPU or our Kinesis processing unit, but basically parallelism per CPU. So basically through the API, you say, I want 100 parallelism, 100 cores. I would like 800 parallelism, 100 cores. That type of thing. And that's why you would provision it yourself. Does that answer your question?
Yes. Thanks.
So I think we're out of time. Thank you all very much for attending. And have a good rest of the conference.
Thank you very much, Ryan, for the great talk.